Walaikum salam, everyone. Hope you guys are doing well. I'm just reading your messages now. I am sitting for the November 2022 O-level exam on Monday. Alright, good luck to you. This is for you guys only. Actually, for all those who are sitting for October, November. Okay. So, how well prepared are you guys for the exam? On a scale of 1 to 10? 8 out of 10. Okay, that's not bad. 2. Ouch. Let's see, huh? That's not a good state to be in. 8. Okay, that's not bad. That's pretty good. 9 out of 10. Not bad. Not bad. Okay. So, anyway, let's start, shall we? So basically today's agenda is that we're going to do vectors, okay, and we're going to do questions related to constant velocity, okay. Now, if you want to learn the concept, I have a separate video on the concept, okay. You can either watch that first and then you can later on watch the live stream, or if you've done the concepts, then you can watch the live stream, and hopefully you'll have a clear idea of what's going on, okay. So we're starting with, as I mentioned, we're starting with past repercussions. And by the way, I've attached the PDF of this and also my notes. You'll find a link in the description of this video, which contains my notes as well as the past reper questions. Okay, so go ahead, download them, make the best of them, share them with your friends, classmates, whoever you think can possibly benefit from it. So anyway, this topic is not very frequently tested. Okay, in fact, a lot of students think that this is actually not part of the syllabus anymore. That's not the case. It's still very much part of the syllabus. In fact, I did a whole video showing students that it's part of the syllabus. Okay, so I'm not going to go into that today. This is from May-June 2019, paper 11. Okay. So let's see what it says and see how we can work this out. So it says a particle P is moving with a velocity 20 meters per second in the direction 3, 4. Okay. And what is it that you're asked to find? You're asked to find the velocity. Okay. So let's think about it, that if we're given the speed, so why exactly is the question asking us to find the velocity? What's the difference between speed and velocity? The difference between speed and velocity is that speed is just a fixed value, okay? By looking at the speed of a particle, you cannot tell in which direction it's heading in. Velocity is something that gives us the direction as well as the magnitude. Okay, science students would know what I'm talking about. Non-science students, just remember that speed is just a magnitude. It has no direction. Velocity is a magnitude as well as direction. Now, one thing that you should know about calculating velocity is that velocity can be worked out two ways. Okay, one is that you can take speed and multiply it by the unit vector of direction. Okay, so how can we work out velocity? You can take the speed and multiply it by the unit vector of direction. Now the question is, how do you calculate a unit vector? Unit vector is basically any vector divided by its magnitude. Okay, so let's apply that over here. So speed, as you can see, is 20. Okay, multiply that by the unit vector of direction, so that means multiplying that by, so 3, 4, so can I write this as 3i plus 4j? Okay, you don't really have to write it like this, but you can also write it like this, divide by the magnitude. And how do you calculate magnitude? Magnitude is basically square root of a square or x square plus b squared. So if you work this out, notice what happens. So 20 into 3i plus 4j over 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of which is equal to 5. So 5 ones are, 5 fours are. Now if you cross multiply, 4 into 3 is 12i, and 4 into 4 is 16. So 12i plus 16j, or you can write it in column vector form also. And in column vector form, it's going to be 12 and 16. And there you go. That's it. You are done with the first part. Okay. So fairly simple. And that's where the story ends. I mean, that's where part A ends. So part 2 says at time t equals to 0, P has position vector 1, 2 relative to a fixed point O. Write down the position vector of P after t seconds. Okay. So in order to write down the position vector of position vector of P, this is what you're going to do. You're going to see where exactly is it starting from, okay? And it's starting from, it's not starting from the origin, okay? It's starting from a point 1, 2, okay? So that means that you will first write that down, 1, 2, okay? And every second, it's moving in this direction, okay? It's moving in the direction of 12, 16. That means every second it moves. You can sort of set 12 units to the right and 16 units up, because 12, 16 means that x is 12, which is the horizontal component, and y is 16, which is the vertical component. So that means this is 12, this is 16. So where exactly will the particle be after t seconds? So for that, we just multiply that by t. Yusuf, this is from May June 2019, paper 1, variant 11. Okay. Now, here's part 3. Let's see what part 3 says. Part 3 says a particle Q has position vectors 17, 18. Okay, so that means it's starting from a point which is 17 units to the right and 18 units to the top, okay, or 18 units above, relative to a time t equals to 0 seconds, and has velocity 8 and 12 meters per second. So that means if I want to write down the position vector of Q after t seconds, this is how it's going to be. 17, 18, okay, plus every second it's moving, you can say 8 meters to the right and 12 meters above, okay, so 8 and 12. So where exactly will particle Q be after t seconds? So for that, we'll multiply that by 2, okay. And what about, and let's read the question further, see what it says. It says, given that P and Q collide, okay. So whenever you see the word collide, or whenever the question is talking about collision, interception, meeting each other, crossing each other, what we do is we equate the respective position vectors. Okay, and that's exactly what we're going to do. We're going to equate the respective position vectors. And when we do that, what we will have is the value of t when these two particles collide. Okay. So what exactly was the position vector of OP? The position vector for OP was this, 1, 2 plus 12 and 16 t. Okay. So like I said, we're going to equate the two position vectors. So OP equals to OQ. So as far as OP is concerned, so we're going to multiply these two. We're going to multiply the vector by t. So this becomes 17 plus 8t. Okay. And then we have 18 plus 12t. So that's one vector. Okay. And then as far as OQ is concerned, so OQ is going to be 1 plus 12t, 2 plus 16t. Please remember not to treat it like a fraction. Okay, this is not a fraction. A lot of times students end up writing the fraction line. Okay, it's a vector. Now, in order to find out the value of t, you could equate 17 plus 8t with 1 plus 12t. Okay, you're going to get the same value of t. Or you could compare 18 plus 12t with 2 plus 16t. It doesn't matter what two values you equate, you're going to get the same answer. So 17 plus 8t is equals to 1 plus 12t. So we move 1 over to the left hand side. So 17 minus 1 is 16. And we move 8 over to the right hand side. So that's 12t minus 8t. Let's write this nicely. So 4t is equals to 16, which means t is equals to what? T is equals to 4 seconds. And this is not where the question ends. The question further says that find the value of t when they collide. So we can sort of put a check mark there. But it also says find the position vector of the point of collision. So if you want to find out the position vector of the point of collision, you're going to take this value of t. You can either plug it in OP or you can plug it in OQ. Since they're both equal, doesn't matter. You're going to get the same answer. So I'm going to plug this in OP. So in place of 8, I'm going to write 4. In place of t, sorry, I'm going to write 4 in both the components x and y. So 12 times 4, there you go. So if you work this out, let's see what you have. You have OP is equals to 17 plus 32 and 18 plus 12 into 4 is 24. Double of 24 is 48. Okay, so let's sum this up. Let's see what you get. OP is equal to, let's see, what do we have? 49 and 66. There you go. And that's it. We are done with this question. And hopefully you've understood what I've done. Okay, now, so I already have a video on this question, okay, and this question is quite a challenging question, okay, so which is why, like I said, since I already have a video on it, I'm going to skip this, okay, and I'm going to move to another question, which is right over here, okay, and this question, I should mention, is from October-November 2016, paper 2, variant 3, okay. Let's solve this question. So the question says, in this question, I is a vector due east and j is a vector due north. Unit of length and velocity are meters and meters per second respectively. Okay. The initial position vectors of A and B relative to a fixed point O are 15i and q minus 15j. Okay. A and B start moving at the same time. A moves with a velocity of p minus 3ij and B moves with a velocity of 3i minus j. Given that A travels with a speed of 5 meters per second, find the value of the positive constant p. Okay, so one thing that you should remember is that the magnitude of velocity gives speed. Okay, yeah, speed is magnitude. Good job, Yusuf. So basically, what are we talking about? We're talking about A. Okay, so A has velocity pi plus 3j. Okay, so let's write that down over here. VA basically means velocity of particle A. So pi minus 3j. And if the speed is equal to 5, not according to me, but according to the question, so that means p squared plus minus 3 squared inside the square root is equal to what? Is equal to 5. Alright, so let's work this out. So we have p square plus 9. So we square both sides, so we get p square equals to... Okay, so let me just show you what I've done. So we've squared both sides. Okay, so we have p square plus 9, which is equal to 25, which means p square is equals to 16, which means p is equals to plus minus 4. Now, since the question is asking you to write down the positive value of constant p, so that means p is equals to 4. Alright. Speed is magnitude. Yeah, that's correct, sir. Do you know Hamza from Nixer? Yeah, of course. I work with Sir Hamza. I know him very well. Ali. Oh, good to see you, Ali. How have you been? Sir, in the AS Math Pure 1, there are 3 chapters combined that makes 1 question. This comes as an 8 marker. At least 1 question will appear. How do we tackle this type? Can you make a video on it? Okay, so AS videos I'll do later. Okay, so these videos are for students who have their exam on Monday and on Friday. Okay, so AS videos I'll do later. All right. Okay. Part 2. Part 2 says find the direction of motion of B as a bearing correct to the nearest degree. Okay. Direction of motion of B as a bearing correct to the nearest degree. Okay, so let's talk about the velocity of B. That's going to give us an idea. So if you look at the velocity of B, it's equal to 3i minus j. So question for you guys. Using the velocity, how can we calculate the bearing? Let's see how well you guys know this. Oh, and by the way, this is B, not A. Yeah. Use a diagram. Thank you, Ali. Yeah, I've made some major changes ever since. Yeah, use a diagram. Okay, so let's start with the diagram. So notice how the question says 3i minus j. Okay, so how do we incorporate that in a diagram? That means it's moving 3 units to the right. Okay, and minus j means it's moving 1 unit down. Okay, so altogether the question is, the object is actually moving in the direction of the red arrow. Okay, so this is the direction in which the object is moving. Okay, so this right here, yep, we'll have to use trigonometry. This is 3 and this is 1. Now, if the question is asking you for the bearing, that means the question is asking you for the angle this makes from the north in a clockwise direction. So this is the question. This is basically what the question is asking you for. Okay. So once you establish what angle the question is asking you for, 251.6. Are you sure about that? It's 200. Okay. I don't think it's 200. I think it's got to be in between 90 and 180. Okay. So this is the angle that we'll have to find. Okay. So how do you find this angle? Let's see. This is the opposite length. Okay. And the length that we have is the adjacent length. So what trigonometric ratio can we use over here? We can use tan. All right. So tan, let's call this theta. Tan theta equals to 1 upon 3. That means theta is equals to, let's find out, the tan inverse of 1 upon 3. So you have 18.4. Okay. Now don't get carried away and think 18.4 is your answer. The answer will be worked out. So the bearing will be 90 plus 18.4 degrees. Okay. So let's work this out. Plus 90. So that's 108.4. Okay, so take a good look at what I've done and see if this makes sense to you or not. And this is from October, November 2016. Paper 2, variant 3. Yeah. Okay, so let's move on to the next part. Okay, let's see what the next part says. So could you do the question vector bearing? Okay, so I plan on solving the whole paper in a live stream, hopefully tomorrow, since I just realized we don't have a lot of time left. Okay, so that's why I skipped the 20, what do you call? By the way, I just realized that the final answer is actually going to be 108 because I just read it says correct to the nearest degree. So while 108.4 is correct, it's not going to be accepted as the final answer. It has to be 108. Okay. All right, here's part 3. Part 3 says state the position vector of A after 3 seconds. So how do you write the position vector of A after 3 seconds? You start by writing down the point at which it's starting from. Okay. So the point at which it's starting from is 1, 5. So there you go, 1, 5 plus the velocity vector times t. So what's the velocity vector? So we worked out the velocity vector. P turned out to be 4. So that means 4 and minus 3. 4 and minus 3 times t. Okay. Then we do part 4 where it says state the position vector of B after t seconds. And I think in the next part they're likely to collide. Anyway, we'll see when we get to that. So point B is starting from a point that is q and minus 15. So let's write that down, q and minus 15 plus the velocity of B. We already have that. That's 3 and minus 1 times t. There you go. That's it. And we are done with this part. Okay, now part 5 says find the time taken until A and B meet. So whenever two particles meet, what do we do? Question for you guys. When two particles meet, what do we do? When they meet, they collide, or anything along those lines, what do we do? Yep, we equate position vectors. So you equate position vectors. All right, now, so we have the position vector of A. All right, let's copy paste that. And we have the position vector of B. Let's copy paste that. So here's OA and here's OB. So we're going to equate the two. So 1 plus 4t is equals to Q plus 3t. Okay, this is not really going to help us. Okay, but if we do 5 minus 3t, which is equal to minus 15 minus t, This will definitely help us. How? Because now we can solve for the value of t. So 5 plus 15 is 20. So this is what I'm using, okay? This is the equation that I'm using. So 5 plus 15 is 20, which is equal to 2t. And then t is equals to what? T is equals to 10 seconds. And there you go. That's your answer. Okay, now next part. The next part says, find the position vector of A where A and B meet. Okay, so if you want to find out the position vector of A where A and B meet, you can use the value, so basically you can use the value of t that you just found and plug it in. Okay, and that's exactly what I intend to do. So 1 plus 4 into 10 and 5 minus 3 into 10. So let's see what we get. So we get 40 plus 1, so that's 41. And we get 5 minus 30. What is that? That's minus 25. There you go. That's it. That's your answer. Find the value of the constant q. So remember, OA is equals to OB. So now you know what OA is equals to. Okay. So as far as OB is concerned, you can use this equation to find out the value of q. Okay. 1 plus 40. 1 plus 4t is equals to q plus 3t. Okay, so we can use 10 as t. So 1 plus 4 times t is equals to q plus 3 times 10. So 41 is equals to 30 plus q. Let's find out the value of q. So q is equals to 11. And there you go. That's it. We're done with the question. So how many marks was this question worth? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 marks. That's a pretty good deal. Anyway. No. I'm going to skip this question here because it's similar to the first question that I solved. Okay, this, by the way, is from February, March, IGCSE Maths. Okay, so anyone watching from India, this is the question that came in the March session. Okay, not too long ago. Okay, now, in fact, since there aren't many questions, let's do this question. Okay, so change of plans. I am solving this question. Okay, so this question says, in this question, all lengths are in meters and all times are in seconds. Particle A is moving in the direction minus 20 and 21 with a speed of 58. Find the velocity vector of A. All right, so I'll let you guys try this. I'll give you guys 2 minutes. Try this question and share your answer. Remember that if you want to find out the velocity, so you can find out the velocity by taking the speed and multiplying it by the unit vector of direction. So this is from February, March 2002, but IGCSE, not GCE. Okay, although the papers are same, but this February, March session is only held in India. So yeah, this is probably the second last paper. Yeah, so you're going to find the magnitude first, then write it. Yeah, that's what you're going to do. Go ahead. 29 root 2 and 43.1. Are you sure about that? Yeah, that's correct. Minus 40 and 42. October November series only to people who are repeating? No, not really. In some countries, they give the exam in October November only and not in May June. Okay, I think in Mauritius, in Malaysia also. Maybe that's only for this year because they were online initially. So I'm not sure about that. Yeah, minus 40 and 42 is the correct answer. So basically, here's how this works. So you have 58, which you're going to multiply by minus 20i plus 21j divided by their magnitude. So the magnitude is going to be minus 20 squared plus 21 squared. Okay, so this becomes 58 into minus 20i plus 21j over 29, and then if you work this out, 29 ones are, 29 twos are, So now you're looking at minus 40 and 42. Okay, so you can write it however way you want. Okay, that's up to you. Yeah. Yes, Pranav, this is exactly what you're saying. Okay. So here's part B, which says given that A is initially at the point with position vector 5 and minus 3, write down the position vector of A at time t. Okay, so that means the position vector of A, it looks like this, 5 minus 3. And what's the velocity? Now that we know the velocity, so that's minus 40, 42. Okay, multiplied by t. That's it. There you go. A particle B starts to move such that its position vector at time t is this. Find the displacement vector AB at time t. Okay, so if you have the velocity, how do you find the displacement? Let's see. So displacement is the magnitude of velocity. Displacement is the magnitude of velocity. There you go. Okay, no, we're not talking about integration and all that. Okay, so if you have the velocity, okay, and if you differentiate it, okay, wait a minute. Let's read the question again. Okay, so it's asking you for the displacement vector AB. Okay, sorry, my bad. Displacement is the magnitude of velocity, but that doesn't apply over here because here you have to find out the vector AB first. Okay, so let's see how this works. So remember, you have OA. Okay, the question just made you work out OA, so that's 5 minus 40t. Okay, and minus 3 plus 42t. Okay, and now the question has given us OB. Okay, so that's minus 35t plus 4 over 44t minus 2. Yes, that's exactly what we're going to do, Yusuf. If you want to find out, so you have the displacement vector of A, you have the displacement vector of B at time t. So if you want to find out AB, you can do that by simply doing OB minus OA. Okay. So let's do that. Minus 35t plus 4. 44t minus 2, and from this let's subtract OA, which is 5 minus 40t over minus 3 plus 42t. Okay, let's see what happens. Let's see what we get. So AB equals minus 35t plus 4 minus 5 plus 40t. Okay, we'll simplify this in the next step. And then you have 44t minus 2 plus 3 minus 42t. So we'll simplify this in the next step. So let's write down AB now. So minus 35t plus 40t, so that's 5t. 4 minus 5 is minus 1. Okay, there you go. And then 44t minus 42t is 2t. And minus 2 plus 3 is plus 1. And there you go. That's it. Okay, now here's part D. So the last statement that I made was actually slightly incorrect. So distance is basically the magnitude of displacement. Okay, so if you're given the displacement vector, okay, you can find out the magnitude and you will have distance. So we have the displacement vector from A to B, that's 5t minus 1 over 2t plus 1. Now if you want the distance from the point A to B, then what you'll have to do is you'll have to find out the magnitude. That means 5t minus 1, the whole thing squared, plus 2t plus 1, the whole thing squared. And let's work this out step by step. So 5t minus 1, the whole thing squared. Let's see what is that equal to. Please don't forget to use the identity here. So that's going to be equal to 25t square plus 10t minus 1 plus 4t square plus 4t plus 1. There you go. Let's sum this up. So 25 plus 4 is 29t square. 10t plus 4t is 14t. And minus 1 plus 1 gets cancelled out. Is that the case? Let's see. Let me make sure that I've done it correctly. Actually, it's going to be plus 1 and plus 1. So that's going to be plus 2. Sorry, my bad. Since it's a square minus 2ab plus b square. So there you go. So 29t square plus 14t plus 2. And okay, yeah, you're right. This is going to be minus 10t. So minus 10t plus 4t is going to be minus 6t. Okay, let me just double check. So 25t square minus 10t plus 1 plus 4t square plus 4t plus 1. Yep, so far so good. So minus 10 plus 4 is minus 6. Yeah, that's correct. Okay, thank you for pointing that out. Okay, then it says find the value of t for when the distance AB is root 6. So now what we're going to do is we have the distance in terms of t. Okay, one thing you should know about t is that it's always positive because time, as we know, is always positive. So square root of this, the distance, is equal to square root of 6. So now we have ourselves a quadratic equation which we're going to solve. So 29t square minus 6t plus 2 minus 6 equals to 0. And let's solve this. So 29t square minus 6t minus 4 equals to 0. So for this, we'll have to use the quadratic formula, okay, which I hope you guys remember. Minus b plus minus square root of v squared minus 4ac upon 2a. Okay, so let's solve this. So t is equals to minus 6 plus minus square root of minus 6 squared minus 4 into 29 into minus 4 divided by 2 into 29. So okay, so I'm going to use the calculator to just to be on the safe side. Okay, and if you use the calculator and solve this equation, let's see what you get. And make sure that you guys use your calculator just to check your answer. Okay, don't skip the working and just use the calculator and write the final answer. That's not something I would recommend, but I will strongly recommend to use a calculator to check your answer. So we get 0.49. Remember that you have to give your answer correct to 2 decimal places, or you get t is equals to minus 0.282. Okay, so obviously we're not going to give this value, so we scratch that and we write 0.49 seconds as our final answer. And there you go. That's it. We are now done. Okay, so that's it for this stream. All right, I hope you guys understood and also enjoyed. Tomorrow, inshallah, we will... What are we doing tomorrow? I think we're doing functions tomorrow. Anyway, so I've uploaded the schedule on my Instagram. You can check it out from there. So we'll do functions tomorrow. We'll do some past paper questions of functions. We'll learn how to find the domain and range. And yeah, that's it. Like I said, I've uploaded this PDF. You can download it. It's in the link is provided in the description. Okay. So take care, everyone. Allah Hafiz. You're welcome.